This video is about how parameters change the graph of quadratic functions. For standard form, y equals ax squared plus bx plus c, a is not equal to 0. When a greater than 0, the graph opens up. When a less than 0, the graph opens down. When absolute value of a gets larger, the graph gets narrower because y value will increase faster. When absolute value of a gets smaller, the graph gets wider. For this c, f of 0 equals c. So c is the y-intercept of a quadratic function. When c less than 0, y-intercept is below x-axis. When c equals 0, means the y-intercept is 0, 0, origin. When c greater than 0, y-intercept is above x-axis. Let's sketch the graph. C less than 0. The graph could be like this. For c equals 0, the graph will cross x-axis at the origin. When c greater than 0, y-intercept is above x-axis. For parameter b, it's dealing with the vertex. We do know x equals negative b over 2a is the axis of symmetry. Negative b over 2a is also x coordinate of vertex. Therefore, when negative b over 2a greater than 0, the vertex is on the right side of y-axis. If negative b over 2a equals 0, the vertex is on the y-axis. When negative b over 2a less than 0, the vertex is on the left side of y-axis. Let's go to next topic. How to determine the sign for a and b. In quadratic function, y equals ax squared plus bx plus c. We do know the vertex of a quadratic function is hk. H equals negative b over 2a. So k equals f of negative b over 2a. If you are given a graph, the vertex is on the left side of y-axis, like this diagram. The vertex x coordinate is negative. H equals negative b over 2a less than 0, which means b over 2a is positive. For a fraction, either both numerator and denominator are positive, or both are negative. Then this fraction greater than 0. For example, 2 over 3 greater than 0. Negative 2 over negative 3 equals 2 over 3 greater than 0. In other words, A and B have the same sign. Both are positive or both are negative. If A is positive, then B is also positive. If A is negative, B is also negative. For example, since a quadratic function opens down, A less than 0, B also less than 0. For this quadratic function, the graph opens up, A greater than 0. Since the vertex is on the left side of y-axis, B also greater than 0. Let's check the other situation. If the vertex is on the right side of y-axis, this h is positive. H equals negative b over 2a greater than 0. B over 2a will be less than 0. Since this is a fraction, we do know negative 2 over 3 less than 0, or 2 over negative 3 also less than 0, which means the numerator and the denominator have the different sign. If A is positive, then B is negative. If A is negative, B is positive. This graph opens up means A greater than 0. Since the vertex is on the right side of this y-axis, B is negative. Check this graph. The graph opens down means A is negative. Since the vertex is on the right side of y-axis, this B is greater than 0. Question 3. Consider the following graphs of quadratic functions. The equation of each of the quadratic functions can be written in the form y equals ax squared plus bx plus c, where a is not equal to 0. Each of the sets of conditions for constants a, b, and c in the table below, corresponding to one of the graphs above. Write down the number of the corresponding graph next to each set of conditions. We are given these 6 graphs. Let's check A first. When graph opens up, means A is positive. When graph opens down, means A is negative. We know C is the y-intercept. First graph, y-intercept is 0. For graph 2, y-intercept is positive. Graph 3, y-intercept is negative. For graph 4, y-intercept is negative. For graph 5, y-intercept is 0. For graph 6, y-intercept is positive. B is dealing with the vertex. H equals negative b over 2a. So when b equals 0, vertex will be 0k, which means the vertex is on y-axis, on y-axis, which means b equals 0, b equals 0. This also means x equals 0 is the axis of symmetry. Next step, we need to check vertex. This vertex is on the left side of y-axis, means negative b over 2a less than 0. This also on the left side of y-axis, negative b over 2a less than 0. Vertex is on the right side of this y-axis, negative b over 2a is positive. Same to this vertex, negative b over 2a is greater than 0. This means b over 2a is positive. B and a have the same sign. When a is less than 0, b less than 0. Same sign for a and b. A is greater than 0, means b greater than 0. For this vertex, b over 2a is negative. A and b have the different sign. B is less than 0. Same to graph 3. When a less than 0 means b is greater than 0. So this is the answer. Question 4. The diagram shows the graph of the quadratic function f of x equals ax squared plus bx plus c with the vertex negative 2, 10. The equation f of x equals k has two solutions. One of these solutions is x equals 2. Write down the other solution of f of x equals k. Let's draw y equals k. We have two intersections. This intersection, x equals 2. We do know x equals negative 2 is the axis of symmetry. Let's label this is x2. Negative 2 is the middle point for x2 and this 2. We can set up the equation negative 2 equals x2 plus 2 over 2 over 1 cross multiply. X2 plus 2 equals negative 4. So minus 2 both sides. X2 equals negative 6. B. Complete the table below, placing a tick to show whether the unknown parameters a and b are positive, 0, or negative. The rule for C has been completed as an example. We know C is a v-intercept. This is C. C is a positive. Since the graph opens down, A is a negative. Then check the vertex. We do know negative b over 2a equals negative 2. It's less than 0, which means b over 2a is positive. B and a have the same sign. Since a is negative, so b is also negative. C. State the values of x for which f of x is decreasing. F of x is decreasing means when x is increasing, then f of x is decreasing. This part of the graph is decreasing. X value will be this. So when x greater than or equal to -2, f of x is decreasing.